guys, so today we're going to be studying Bessel's differential equation. So the differential equation of the form x square y dash double dash plus xy dash plus x square minus n square into y is equal to 0. This is nothing but the Bessel's differential equation, the standard form, where n is nothing but a real number. So the series solution of the Bessel's equation. So this is nothing but the equation as above. Over here, x is equal to 0 is again a regular singular point. So we take y dash and y double dash as we have always done. Y is equal to summation of k is equal to 0 to infinity. Ak x bar k plus m. Y dash is equal to summation of k is equal to 0 to infinity. K plus m ak x bar k plus m minus 1. Y double dash is equal to summation of k is equal to 0 to infinity. K plus m into k plus m minus 1 ak x bar k plus m minus 2. These are the three equations formulae that we have always studied. Now putting y dash y double dash in this equation number 1, what do we get? We'll get this, right? And then we take the x inside the bracket. So when that happens, we'll get the same thing as over here, and it'll become k plus m minus 2 plus 2. That becomes k plus m, right? Over here, when we are taking the x inside, it'll become k plus m minus 1 plus 1. It becomes k plus m. Over here, we can open up this bracket. So it becomes x square into this minus n square into this. So minus n square into this, we'll keep it out. And x square, we'll take it inside. So when that happens, we'll get ak x bar k plus m plus 2. So we'll get this, right? And we'll have our minus n square into this. So we'll keep that as it is equal to 0. Now what do? Now we have a lot of x bar k plus m, right? We have this and this. So we'll take that common. So ak over here, x bar k plus m, we'll take it out. And we'll put in all the remaining contents inside the bracket. Okay? So we'll get summation of k is equal to 0 to infinity. K plus m into k plus m minus 1 plus k plus m minus n square into your ak x bar k plus m, right? Plus summation of k is equal to 0 to infinity. ak x bar k plus m plus 2 is equal to 0. है ना? ठीक है. उसके बाद what do? We have it in this form. Now on opening up the brackets and doing the needful, we'll get k plus m the whole square minus n square remains the same into ak x bar k plus m plus this term remains as it is equal to 0. This will form our second equation. Now on equating the lowest power of x, that's nothing but the coefficient of x bar m to 0 for k is equal to 0. So over here, when k is equal to 0, we substitute the lowest power of x. What is the lowest power of x? This term. So the coefficient will be equating it to what? 0 for k is equal to 0. So when k is equal to 0, we'll have m square minus n square into a naught. K is equal to 0, right? So a naught is equal to 0. We are equating the coefficient of the lowest power of x to 0. Over here, so m square minus n square into a naught is equal to 0. So our m square minus n square is equal to 0. So what will be our m? M is nothing but the root of our equation, right? So what does m come out to be? M is nothing but plus or minus 1. Because a naught cannot be 0, right? So m is equal to plus or minus 1. So this part of the equation is equal to 0. M is equal to plus or minus n. Now we equate the coefficients of x bar m plus 1 from equation 2. From equation 2, we equate the x bar m plus 1's coefficient to 0. Now on doing that, we get m plus 1 the whole square minus n square into a1 is equal to 0. So what is our a1? a1 comes out to be 0. Why? Because m plus 1 the whole square minus n square is not equal to 0 for m is equal to plus or minus n. Now we equate the coefficients of x bar m plus k x bar m plus k plus 2, and it provides the recurrence relation for the Bessel equation from equation 2, right? So what do we get? We get m plus k plus 2 into the whole square minus n square into ak plus 2 plus ak is equal to 0. So our ak plus 2 is equal to minus ak divided by m plus k plus 2 the whole square minus n square. So where our k is equal to 0, 1, 2, 3, etc. This is nothing but our required recurrence relation, where a1 is equal to a2 is equal a3 is equal to a5, all odd numbers, all of them equal to 0 for k is equal to 1, 3, 5, 7, etc. Right? And a2 is equal to a0 divided by m plus 2 the whole square minus n square. a4 is equal to minus a2 divided by m plus 4 the whole square minus n square plus a0 divided by so on and so forth. Yeah, on expanding, this is nothing but a square minus b square formula. Okay? Now we put ak, we put all the values that we have found out. So a1, a2, a3, all everything that we have found out into y. So y is equal to summation of k is equal to 0 to infinity ak y bar x bar k plus m, right? So that is nothing but equal to a0 x bar m plus a1 x bar m plus 1 plus a2 x bar m plus 2 plus a3 x bar m plus 3 and so on and so forth. So that is equal to a0 x bar m plus 0 minus a0 So now we put y is equal to a0 x bar m plus 0 minus a0 divided by m plus 2 the whole square minus n square x bar m plus 2 plus 0 plus a0 x bar m plus 4 divided by m plus 2 the whole square minus n square into m plus 4 the whole square minus n square and so on and so forth, right? So y is equal to a0 x bar m into 1 minus x square divided by m plus 2 the whole square minus n square plus x bar 4 divided by m plus 2 the whole square minus n square, and this, right? So based on the value of n1, we get the different values of different types of solutions. And if n is not an integer and the roots are different and the roots differ by the integer, then the solution is this. This is very important. Y is equal to c1 yn plus c2 y minus n. So on this will be your equation number 4. So by putting m is equal to n in equation number 3, in equation number 3 we equate m is equal to n, then we get y of n is equal to a0 x bar n into 1 minus x square divided by 2 into 2n plus 2 plus x bar 4 divided by 2 into 4 into 2n plus 2 into 2n plus 4 and so on and so forth. And on further evaluating, we will finally get a0 x bar n summation of k is equal to 0 to infinity minus 1 bar k x bar 2k factorial of n plus 1 divided by 2 bar 2k k factorial into factorial of n plus 1 into n plus 1 plus n plus 2 into n plus k and so on and so forth up to n plus k, where n factorial is equal to factorial of n plus 1. Gamma of n plus 1. Sorry, this is gamma, right? Yes. So n factorial is equal to gamma of n plus 1. So yn is equal to a0 x bar n summation of k is equal to 0 to infinity minus 1 bar k x bar 2k into factorial of into gamma of n plus 1 divided by 2 to the power 2k k factorial into n into gamma of n plus k plus 1. So now a0 comes out to be an arbitrary point. So let's take a0 equal to 1 divided by 2n into gamma of n plus 2. So yn comes out to be, on further evaluating, what does yn come out to be? It comes out to be summation of k is equal to 0 to infinity minus 1 power k divided by factorial of k into gamma of n plus k plus 1 into x by 2 to the power 2k plus 1. This will be your fifth equation. This is nothing but the Bessel's equation of the first order, and it is also given by jn into x. Similarly, for m is equal to minus n, we will further evaluate. That is nothing but all of these. This was the proof, so that's why I've just generally shown it to you. Okay, over here y base minus n is equal to summation of k is equal to 0 to infinity minus 1 to the power k divided by k factorial into gamma of k minus n plus 1 into x by 2 to the power n minus n plus 2k. This will be your sixth equation. This is nothing but the Bessel's function of the first kind of order of minus n. So this is of order n, and over here it is minus n. Okay, and the complete solution is y is equal to c1 jn of x plus c2 j of minus n of x.